A very warm good morning to all dignitaries, distinguished delegates, faculty members and student friends. On behalf of Manipal Institute of Technology Bengaluru and Manipal Institute of Regenerative Medicine under the Manipal Academy of Higher Education Bengaluru, we welcome you all to the celebration of National Science Day 2023. Science is not meant to cure us a mystery, but to reinvent and reinvigorate it. What you learn from life in science is the vastness of our ignorance. Equipped with his five senses, man explores the universe around him and calls the adventure science. 28th February is celebrated as National Science Day in India since 1928 to mark the discovery of the Raman effect by Sir C.V. Raman, the renowned Indian physicist. For the discovery, he was also awarded with Nobel Prize in Physics in 1930. This day was designated by National Council for Science and Technology Communication to commemorate this achievement. The main objective of National Science Day is to bring awareness to people about the importance of science in our daily life and to encourage people by popularizing science and technology. Every year, the day is celebrated with a particular theme. The theme for National Science Day 2023 is Global Science for Global Well-Being. On the occasion of National Science Day 2023, we at MIT Bengaluru and MIRM Bengaluru have been doing what we do the best by conducting week-long activities for students from 28th to 25th February 2023. Activities included quiz, debate, poster making and audio-visual creation under this year's Science Day theme, Global Science for Global Well-Being. Today, we have the valedictory ceremony of the same, which will include a popular science talk titled Science as a Candle in the Dark by an eminent astrophysicist, Professor P. Ajith, from ICTS-TIFR Bengaluru, followed by prize distribution for the winners of various events. If your actions inspire others to dream more, learn more, do more and become more, you are a leader. May I now request Dr. Utpal Deka, Additional Professor, Department of Physics, Manipal Institute of Technology Bengaluru and Coordinator, National Science Day Celebration 2023 to deliver the welcome address. Sir.
Namaskar, good morning and Sudhya to all, one and all present out here. This is a very memorable day for all of us, as Dr. Ramya has already stated. We are here to commemorate and celebrate the discovery by Dr. Raman. Along with Dr. Raman, this was Dr. K.S. Krishnan and K.R. Raman, his two students who have contributed immensely to the journey of the discovery of Raman effect. So today, this marks the beginning of another yet important event to be celebrated in MIT Bengaluru in the calendars to come. This is the first time that we are celebrating this National Science Day in MIT Bengaluru campus, and it's a proud privilege for us to organize this event. And along with us, MIM, Manipal Institute of Regenerative Medicine, who has co-hosted this program for this final day. Today it is a proud privilege for us to have one of the world's renowned scientists in the area of astrophysics and cosmology, Professor P. Ajith from International Center for Theoretical Sciences, TIFR Bengaluru. He has a lot of accolades for him, and today we'll have the fortunate to hear from Professor Ajith. I welcome you, sir, for this program. We are privileged that this final day is being graced by our beloved Pro Vice Chancellor Madam of Mahe Bengaluru campus, Dr. Padma Madam. I would like to extend my heartiest welcome to you, ma'am. We are also privileged to have our beloved Director, Sir, Dr. Jagannath Karodi, sir, here. with us, and Dean MIRM, Dr. Sudha Warrior, over here. I extend my warm greetings and welcome to all of you. I would like to extend my heartiest welcome and warm greetings to all the HODs from different institutes, from our institutes, distinguished ladies and gentlemen, faculty members and colleagues, and my dear student. Because of you only this event today's morning is successful. I welcome all of you to this very big day for you. As Ramya has already mentioned, I would like to give a brief account. So we thought of celebrating this National Science Day only in last January, and we didn't took much of the time, and directors are readily agreed that you should go forward, and Prof Madam also said that we should have such functions in the institute. And it's a big day that science becomes the foundations of engineering. That's why we are here to celebrate this National Science Day. So here to celebrate, we thought about having a 1 week long program. So we decided to collaborate with Manipal Institute of Regenerative Medicines to host different kinds of events and competitions for the students. Ultimately, students are the driving force for the all institutes. So different programs in both the institutes are co-hosted in our institutes, and students has immensely participated. Around more than 100 students from MIT has participated in the different activities which are called for over 1 week. I would like to give kudos to all the students who has made this program very successful. And to have this function today, this is the final day, even though we are celebrating little bit 3 days in advance, 25th February rather than 28th February. But to make this event a successful one, we have all the force of the teachers who have worked relentlessly for the whole week, more than a week, and we have a good team effort, and all teachers have come together, puts their hands together to make the whole week a successful one. Along with that, we have the students, participants, and the volunteers from the students who are the main force for making this whole program a successful one. With this, I would like also to thank many of our sponsors. We had some sponsors. We are very fortunate to have sponsors who have decided to sponsor for the rolling trophies for the MIT functions or the events, and give some prizes along with the gifts given by the institute. With this, I would like to thank you and welcome you once again. Thank you very much.
Light is a pretty universal symbol of truth, knowledge, and understanding. It acts as a guide, keeping us from stumbling in the dark. We now have the lighting of lamp. May I now request the dignitaries to light the lamp. Thank you, dignitaries. Ultimately, leadership leadership is not about glorious crowning acts. It's about keeping your team focused on a goal and motivated to do their best to achieve it, especially when the stakes are high and the consequences really matter. It is about laying down the groundwork for others' success and then standing back and letting them shine. May I now request Dr. Jagannath Koradi, our beloved Director, MIT Bengaluru, to instigate the program with his words of wisdom. Sir?
Thank you, Dr. Ramya. Very good morning to everyone assembled here for this important function, National Science Day. Professor Ajith, the very famous astrophysicist in India, and very fortunate to have him in Bangalore, very near to us. He is in Yelahanka only, although his office is in Visaraghatta, he is in Yelahanka only. And our Pro-Vice Chancellor, Dr. Pragna Rao, the Dean of MIRM, Dr. Sudha Warrior, all my faculty colleagues, MIRM faculty, other institution faculty, and students of all institutions. And a very warm welcome to you all again from my side. This is, as I said, and as has been told by Dr. Ramya and Dr. Utpal, this is a very important function for all of us. Because especially for engineers, if I am talking from the point of view of engineers, science and engineering cannot be separated. Science is all about knowing, engineering is all about doing, in a very simplest form, if you want to say. Without knowing, we can't do anything. Knowing everything, we don't do anything, that is also not of any use. So, that is why in all engineering curriculum, especially the first year curriculum, there is physics, chemistry, maths, even biology now. Very important part of engineering. Because tomorrow, students can take up interdisciplinary projects. Now the medical field is looking at engineering science, and engineers are looking at medical field. This is very common. So therefore, the science part of engineering or engineering part of science, both are necessary for the advancement in technology and science. But ultimately, any technology which has to come emerge, which is the culmination or the summation of many engineering processes and tools, which have been generated by the knowledge of science. And this cannot be separated at all. So we thought we have to celebrate this day, National Science Day. As we all know, Dr. C.V. Raman, who is a very renowned scientist, India has produced Nobel laureate, on his commemorating his invention of Raman effect. We are observing this day as a National Science Day. But this has to be the benefit of this, the scientific knowledge or the application of this scientific knowledge has to be transferred to the students, because they are the people who are going out after their course and who are going to do the inventions. And what is it, what way we can participate in when you are studying in engineering itself, engineering or any other course. So what kind of projects you can do? So we have already had one level of discussion with the MIRM in this regard, MIRM faculty and our faculty. What kind of collaborative research can be done between us? So anyhow, we are waiting for MIRM to come to this campus to take it more forward and give this benefit to our students. Faculty research is one thing, but faculty research has to involve students. Without involving students, the benefit will not go to them, or they will not understand. So therefore, both the institution, faculty, have to collaborate and do the collaborative research involving students. That is what is my intention, and we have already taken few steps in this regard, and it will be definitely done. From the institution side or from the campus side, we will give all the support. That is what we want. So science, engineering and technology. All these three words today, there will be some confusion. People say engineering and technology is same. Engineering and technology is not the same. Engineering is emerging from science. What is the application of science? What are the tools or devices or processes we do with the application of the scientific knowledge? That is engineering. But engineering has to be taken to the next level. Technology, it has to be clubbed. All the engineering inventions, many of these inventions are put together. It becomes a technology, an useful technology, a technology which can be afforded by people. That is what is the requirement of today, and I hope also, I am very glad that large number of students are interested in this. Of course, engineering, you are studying engineering, but you cannot separate science from it. You should be interested in interdisciplinary projects. You should take up. That is the advantage of our campus. We have here design course, we have here MIRM, we have here other courses, management courses. The advantage of this campus, all students have to derive. I hope this National Science Day, the lecture by the eminent professor will be a very successful one and very interactive one. I hope all the best for this program. Thank you. Thank you very much.
Thank you, sir. The speech was really informative and extremely helpful for these students. The world needs strong women, women who will lift and build others, who will love and be loved, women who live bravely, both tender and fierce, women of indomitable will. A strong woman knows she has strength enough for the journey, but a woman of strength knows it is in the journey where she will become strong. From leading nations to running the world's most important organizations, women continue to shape the world through their leadership. May I now request Dr. Pragna Rao, Pro Vice Chancellor, Bengaluru Campus, Mahi, to deliver the address of the guest of honor. Ma'am.
A very good morning to everyone assembled here, and a special warm welcome to Professor Ajith. Thank you so much for joining us here today. We're really eagerly looking forward to listening to your talk. National Science Day, as everybody has said before me, is a day when we remember that we need to be scientists. And that science, that innovation, that spark of discovery actually comes from observations around us. I remember my second year MBBS student who tore his hair out in frustration looking at health records of patients and decided to build his own electronic record system based on blockchain technology. I didn't know what blockchain meant, but I told him, okay, I'll give you some patient health records. Today, after he finished internship 2 years ago, he owns a company which is valued at more than $5 million. What I meant to say here is it's observation that fuels science. And we all heard of Alexander Fleming, who by chance discovered penicillin. It wasn't by chance. He was actually looking for something which would kill bacteria. And he was actually examining the tears from patients. He would make people cry, literally. In fact, there was a very famous cartoon which showed in those years, many decades ago, there was a cartoon put up of Alexander Fleming literally beating a child, taking the tears and then paying him money for it. Very unethical research, but that was it. And then they were examining those tears for antibacterial activity. So you see, chance helps whatever the mind is prepared to see. Then when there is a significant, let's say a fungus which came and sat on his petri dish and showed that it worked. But then observation, science, all this goes together. So whether it's research, whether it's engineering, whether it's technology, whether it's medicine, science is a way of life. And to all students who are on this campus, we hope that science becomes part of your daily routine, that you use observations in a way which helps you to think differently, to build different tools, to act differently, and for you to take the help not only of the transdisciplinary nature of this campus, but to take the help of MILES. You've all heard of MILES, the center which looks at innovation and entrepreneurship. And we would love to have as many students building their own companies from start, using science, using innovation, using technology. I'd like to congratulate the organizers of this event, both Dr. Utpal Deka, as well as I see the MIRM faculty who have organized it. Thank you so much for being here. And thank the students also for turning out in large numbers. I wish this program all the very best. Thank you.
Thank you, madam, for your inspiring words. I think one of the keys to leadership is recognizing that everybody has gifts and talents. A good leader will learn how to harness those gifts towards the same goal. To do great things is difficult, but to command great things is more difficult. May I now request Dr. Sudha Warrier, Professor and Dean, MIRM, to address the gathering. Ma'am.
Good morning, all. First, let me just introduce you to what is, MIRM. What does it stand for? Quite a lot of people here ask me, what is regenerative medicine? Where does it fit into the scheme of things, in biology? So, Manipal Institute of Regenerative Medicine was conceptualized to cater to the expanding need of qualified stem cell professionals in the healthcare sector as early as 2007. And MIRM takes pride for being India's first consolidated academic and research program in stem cell technology and regenerative biology. We are the first in the arena. And broad aim of the institute is to hone young students towards a career in regenerative medicine, a specific area, and stem cell technology, and generate manpower trained towards stem cell technology and bridge the need for stem cell based therapeutics in India as well as across the world. So basically, regenerative medicine itself offers courses in developmental biology, basics of developmental biology, principles of tissue engineering, and applications of stem cells. So in MIRM itself, it is more of a research-focused institute, and PhD scholars are almost equal to our master's students. We offer PG and master's and PG and PhD courses, and we have a very strong research component with investigators specialized across several areas, cutting-edge research, including cardiovascular regeneration, neuroregeneration, cardiac stem cells, cancer stem cells, transplantation immunology, material research and tissue engineering, and cellular reprogramming, which are emerging technologies. And we had a poster session yesterday by our students covering all these areas. Basically, I would just like to talk a bit about stem cells itself. So stem cell based therapy may finally represent the long-awaited magic bullet for replacing lost tissues, be it injury or burns or wound even, and to diseases as complex as motor neuron disease. So it covers the entire spectrum of regeneration. So whenever there's a tissue lost, stem cells are supposed to technically replace it. And they are essentially the raw material of regenerative medicine itself, the cellular component of regenerative medicine, which is capable of building body parts, tissues, organs, etc. And there are different types of stem cells, and all these stem cells are technically capable of forming any type of the body, like any organ of the body.
And this unique characteristic can be utilized in a wide range of applications in biomedical research, and definitely we would like to collaborate with MIT and other institutes to have a translation aspect to our technologies. An application of these cells to treat disease and damage to the human body form the basis and the future of regenerative medicine using stem cells. And MIT, being one of the pioneer institutes in regenerative medicine in Asia, and being the initial entrant in the field, today will also be a celebration of stem cell advances and a promise for a new generation of treatment for multiple diseases. And I thank our Honorable Professor Pragya Rao for allowing us to showcase MIM here in the Science Day event along with MIT. And I also thank the Director of MIT, Dr. Jagannath Korodi, for his support and to co-conduct the Science Day event here in MIT. And I also thank our MIT faculty, research scholars, MSc students, and even coordinators, Dr. Uttara and Dr. Meenal, for putting the program together in such a short while successfully. And there was a very spirited participation, I hear, of the posters in the pre-session yesterday. Thank you. Thank you, madam, for your impetuous words. Nothing in life is to be feared. It is only to be understood. Now is the time to understand more so that we may fear less. We are so honored and privileged to have an inspiring scientist as the chief guest for this function, Professor P. Ajith from ICTS-TIFR Bengaluru. I request Dr. Manipal, Assistant Professor, Department of Physics, MIT Bengaluru, to introduce the chief guest. Sir.
Thank you, Ramana ma'am. Distinguished guest, esteemed faculty member, my dear students. Since antiquity, humankind has been driven by the thirst of knowledge and desire to understand the mysteries of life and mysteries of the world we live in. To dispel the darkness of the ignorance, we have developed numerous systems of inquiry to satisfy our curiosity. And among all these systems of inquiry, science stands out as the most systematic and profound form of the knowledge. Science has played a transformative role in shaping human civilization and improving our understanding of the natural world. Through scientific discovery, humans have been able to unlock the secret of the universe, develop life-saving medical treatment, and are able to create new technologies. From the discovery of the fire to the invention of the internet, science has brought about significant change in the human society and continue to shape our future. Science serves as a beacon of light in the darkness of ignorance, illuminating the unknown and guiding us forward on the path of progress. Yet, for this progress to continue, we need individuals who are fearless in the pursuit of knowledge and brave enough to tackle the intellectual challenges and hold high the candle of knowledge, leading whole humanity forward. India, our ancient nation, has a rich tradition producing such individuals who have made significant contribution to various domains of knowledge. Today, with great pleasure, I introduce to you one of the shining stars of the Indian scientific legacy. I have great honor to introducing to you Professor P. Ajith, an astrophysicist at ICTS-TIFR Bengaluru, and a true embodiment of the spirit of scientific inquiry. Professor P. Ajith has made numerous groundbreaking contributions to gravitational wave physics and has received widespread recognition for his work. With numerous scientific publications and around 1 lakh citations at such a young age, he has established himself one of the leading experts in the field of gravitational wave physics and astronomy. Professor Ajith has been a core member of LIGO team at Caltech under the mentorship of Professor Keith Thorne. And I hope most of you might be aware that my team discovered the gravity wave in 2016, and very next year, the 2017 Nobel Prize in Physics was awarded for the discovery of gravity waves. Professor Ajith's contribution to the gravitational wave physics is recognized worldwide, and he and his team has been awarded the Special Breakthrough Prize 2016, Special Breakthrough Prize in Fundamental Physics in 2016, and the 2016 Grover Cosmology Prize. Recently, he has awarded TAWAS CS Young Scientist Award for Frontier Science by the World Academy of Science. Professor Ajith has been a Ramanujan Fellow, a CIFR Israeli Global Scholar, and a principal investigator of the Indo-US Center for Extreme Gravity. He is also heading the Max Planck Partner Group on Astrophysical Relativity at ICTS Bengaluru. Professor P. Ajith has been invited to speak at numerous international conferences, universities, and institutions around the world, where he has shared his insights and experience with diverse range of audience. Today, we are privileged to have him here with us to share his knowledge and perspective on the role of science and scientific methods in technological advancement and their impact on social transformation. Without further delay, ladies and gentlemen, please join hands with me to welcoming Professor P. Ajith on the stage and enlighten us.
The next half an hour or so. But there is a danger. Usually these things are studied by philosophers and historians. The practice of science is an area of philosophy. And I'm not a philosopher, I'm not a historian. So I'm really stretching my knowledge here. And my understanding of the practice of science is just as a practitioner of science. Just someone like an artist thinks about their practice as an artist, or a carpenter thinks about a practice of them as a carpenter, right? They don't learn the theory of doing carpenting. They know how to do carpenting, just like we know how we learn as an engineer also. We learn how things work, how things will be designed, but we learn the practice of being engineer or a scientist as apprentices. We work with people. We work in companies or work on a PhD with a senior person and learn the ropes of the trade. So the practice of doing science is also learned by apprenticeship, just like the practice of being engineer is learned by being an apprentice in a company or with an engineer. So these are all very personal or very close sort of reflections, and I do not claim this sort of perspective to be very globally accepted or even very accurate also. So let me, not being a philosopher, but at least in a very broad sense, what science tries to do is to organize the facts about material worlds into very universal concepts, so that one doesn't need to learn all these facts separately. One has a common framework of deriving all the facts, right? That's why, for example, we don't need to if we have a theory, we can derive a lot of things from that. So we would like to organize a large collection of facts into some sort of universal explanations, or universal concepts, like which are fundamental laws of physics or biology, paradigms of biology, etc., etc. And it's very important that we limit the scope of the science. Science only deals with the material world, the physical world. And it doesn't, for example, concerns about values or spirituality or religion, etc. These are really beyond the scope of science. So in that sense, science has a very limited domain of applicability. However, given this domain of applicability, the answers to questions has to be found in the material world itself, in the physical world itself. One cannot invoke supernatural explanations. And the reason is very simple. they are not very useful because supernatural explanations have no predictive power. If you invoke that something, that's for example, very ancient people, right? They did not know how weather phenomena occurred, how lightning happened, how thunders happened. So they attributed to some supernatural powers, and then this is something that is happening. But the problem then you have no way of understanding them, you have no way of predicting them, you have no way of coping up with them. So the answers to scientific questions has to be based on physical, materialistic explanations. One cannot invoke supernatural phenomena to explain the phenomena. And philosophers call this particular way of thinking as methodological naturalism. It's a very fancy word, but let's not worry about that. We're not philosophers. But this very famous biologist, I should say Indian biologist, J.B.S. Haldane, although he was born as a British person, he basically converted his passport to Indian passport, and he spent his later years in Kolkata working at the Indian Statistical Institute, made very, very important contributions to the different aspects of biology. So he has this very nice way of explaining things, and he says, my practice as a scientist is atheistic. That is to say, when I set up an experiment, I assume that no God, angel, or devil is going to interfere with its course. It doesn't mean that scientists have to be atheists. No, there are many practicing religious, many scientists are practicing religious people. But however, one cannot let religious beliefs, natural beliefs, interfere in the practice of science. So one assumes that God or angels or devils will not interfere with my experiment. Whether they exist is a different question. As a scientist, you can, in a personal life, you can have different opinions on that. You can have different personal beliefs on that. But as a practitioner of science, one cannot let these interfere. And another aspect of science is that answers are, there is no holy book. The validity of a scientific theory is based on how well it can explain the natural phenomena, how well it can explain the observations, how well it can explain the experiments in the material world. So you have no commitment to a particular theory. Right? If a new theory is found which can explain a natural phenomena better than the previous theory, it has to give way to the new theory. Or also, if theory is unable to explain certain observations, then it means that theory is either wrong or incomplete. So you have no particular adherence to a theory. And this also means that no theory is final also. Here is an actual philosopher, Karl Popper, who actually thought a lot about how scientists practice science by looking at the practice of the modern science. And so he says, every explanation may be further explained by a theory or a conjecture with a higher degree of universality or accuracy, actually. So this is would sound a bit vague to all of you at this point. But let me explain this with a specific example. And the field of science that I'm most familiar with is physics. So I'll be basing all my examples on physics. In some sense, these are also the simplest examples also, because the methodology of physics in some sense is the simplest and that is more understandable in my opinion, at least. So as I told earlier, people have always wondered about how the world works, about the universe. And there is a lot of archaeological evidence that even ancient human beings were curious about what is happening in the heavens. There are cave paintings that are as old as 10,000 years, which have pictures of stars and so on. So and this is like well before humans started agriculture, and they were just living as cave people and hunter-gatherers, etc. It's very clear that the curiosity is very inborn to our species. The skies had practically nothing to do with them, right? At that time. So, and systematic study of the heavens has started at least in a few thousand years. Many civilizations, including the Indian subcontinent, have made significant contributions to the evolution of astronomical knowledge. And people have observed these skies systematically for a long time. And as any of you have seen, that the whole field of stars have a very simple motion, that they all move together. However, if you look at certain objects very carefully at different days and try to connect their paths, they form very complicated paths. These are the planets like Venus or Jupiter that we see even with naked eyes. And in fact, the word planet comes from the Greek word that means wanderers. They are wanderers in the sky, unlike the usual stars, which form a very systematic path at every night. These at different days of the month, these planets come at different points, and they have very, very peculiar motions. They have formed loops and so on. So one big challenge for ancient astronomers was how to explain this motion of these stars. And again, this idea of explaining this natural phenomena using natural models, simple material models, again also have at least centuries of history of a few thousand years, started from the ancient Greeks that recorded their observations. So they have constructed these models in which they assume that there are different made of crystal, and all these stars are distant stars are stuck on the most distant crystal ball, and then there are other objects which are in some other crystals, and they move in a very complicated motion. And people were able to derive fairly mathematical models which explain the observations quite reasonably well. And it is usually attributed to this person, Ptolemy, who wrote this very big treatise called Amalgus. And their model that basically, it is very obvious, it's very natural to imagine that the Earth is the center of the universe because everything is seen to be moving around us. But then if you want to explain the motion of all the planets, it requires them to move in a very complicated orbits around the Earth. So one idea that they have is this idea of these epicycles, in which these planets move in some orbits, but on top of that, they will also move around some circular motion around these orbits also. If you want to again match these model with observation, it has to involve very complicated motions, but still it didn't really quite observe with all the match with all the precise observations. But then this Polish scientist, we call now, natural philosopher, Copernicus, has a very different idea. So he said that if you place the sun at the center of the solar system, then you can basically explain all these apparent motion of these planets just from simple circular motions around the sun. So the fact that they appear to be moving in some very complicated orbits happens to be because we are also moving in a circular orbit around the sun, and we have this very complicated relative motion between other planets. So that really made the theory much more simple, right? You don't have to have these very complicated models, and it has a much larger degree of explanatory power. It can explain all these observed motions with much better accuracy than these very complicated models that was put forward by Ptolemy and so on. And then Kepler, a few decades ago, who had a slightly better idea, that he in fact showed by looking at very precise astronomical observations, again pre-telescope, that if you assume that these planets are moving in slightly elliptical orbits, then you, instead of circular orbits as assumed by Copernicus, then you can explain the observations even better. Not only that, Kepler was able to write down precise mathematical formulas that describe the motion of these planets. These are now called Kepler's laws, and most of you, or some of you, must have studied this in the first year of college. They are very foundations of classical mechanics, etc. So, and now we know that basically all the planets most of the planets in the solar system can be described. You can describe all these things with very precise mathematical formulas called Kepler's laws of motion. It means like which basically provides specific relations between the separation of the planet from the sun and its angular velocity, etc., etc. But again, Kepler had no idea why the planets are moving like this. He had this empirical formula that describes how this motion as a function of time, etc., but no explanation why they are moving like this. And then came Newton, who made really a big, huge intellectual revolution. Basically, Newton argued that precisely the same force that is causing the fall of an apple here on the Earth is also causing the motion of the planets around the sun. So if you are able to write down this Newton's force law that everyone learns in school, that relates how the force is proportional to the mass of the two interacting bodies and is inversely proportional to the square of the distance between them. The same force law can be used to actually derive Kepler's laws. So it's a remarkable decree. The fact that the same laws that operate here on Earth is the same laws that determine the motion of heavens. That was a huge intellectual revolution. You cannot imagine the impact of such a discovery at that time. We all take it obvious now. It was far from obvious that the laws are the same here on the Earth and the heavens at that time. And so this means that you can now explain all the planets around the sun using Newtonian gravity. And in fact, by studying the motion of the existing planets, people were able to predict the existence of new planets. For example, by studying the motion of Uranus, people predicted that there should be an extra planet called Neptune, and then astronomers were later able to observe it. It's a remarkable success of a new theory, right? So let's say, here comes this idea of universality. If you have a successful theory, it should be able to make new predictions, and people should be able to verify these new predictions using experiments or observations. So that you're getting a more and more universal and accurate theory. But here, again, it doesn't mean that Newton's law is the most accurate of gravity. If you try to observe the motion of the innermost planet, the Mercury, unlike the outer planets, these orbits don't follow a pure elliptical orbit. In fact, these orbits don't close. They have this sort of spiral shape, like this. This phenomenon is called precession. And most of this precession is caused by the fact that there are other planets in the solar system, especially Jupiter, which is quite massive, which is adding some additional gravitational force onto this planet, not only the sun. So that is causing most of this precession. But it turns out that even if you account for all the known planets, the gravitational force of all the known planets in the solar system, you could not explain the observed motion of the Mercury. So just by taking the example of Neptune, people predicted at that time that there must be an additional planet, and they called it a name called Vulcan, and that should be very close to the Mercury. And astronomers tried very, very hard to look for it. But not always the same technique would work. So no success of finding this new planet. And then came Einstein, who basically revolutionized our understanding of the theory of gravity. We all learned from school, Newton describes gravity as a force that any massive object would produce in between them. But Einstein has a very different description of gravity, and it is very, very well motivated because there was a lot of experiments at the time that measured universality of the speed of light, etc. But anyway, the description of gravity that is provided by Einstein is that gravity is a manifestation of the curvature of space-time. Gravity curves the space around it. Gravity affects the flow of time. It's very hard to imagine, but there is a very precise mathematical theory, precise mathematical equations that give predictions. And it turns out that you can derive all the Newton's equations from Einstein's theory. And also, when you apply this Einstein's theory to strongly gravitating regions, so for example, regions very close to the sun where the gravity has to be much stronger than here, then it turns out that the predictions of the orbital planet as by Einstein's theory would differ slightly from Newton's theory. And in fact, the observations totally agreed with the prediction of Einstein's theory. So we have further refined our understanding of gravity. It doesn't mean that Newton's theory is totally wrong, right? Because even the rocket science is based on Newton's theory. If you just want to launch a rocket, you just need Newton's theory. Most of the time, Newton's theory works very well. Only in the extremely strong gravity regions near the gravitational field of the sun or close to a black hole, etc., these Einstein's theory makes a remarkable departure. So it gives a next level of refinement to understanding of theory. Not only that, just like Newton made a number of predictions, Newton's theory made a number of predictions, Einstein's theory also made some number of very dramatic predictions. One is that light that usually travels in a straight line, in the presence of gravity, the light would bend. That is a prediction of Einstein's theory. The prediction is that the description is that gravity basically curves the space-time, and light would just follow the curved path of the curved space-time, and that light would actually bend. So this is again one can actually verify using astronomical observations. So here is a setting. If suppose there is a star very, very far away from the sun, but whose rays are basically grazing the limb of the sun, and an observer who is looking at from this side would see that the light is actually coming from here. Right? So you would see the position of the star to be shifted. So you see the star where it is not actually there. So you see a shift in the position of star. And so, for example, if you were to take a photograph of the stars around the sun, what you would see is that these stars are located at these red points here, but their actual positions are shown by these blue points, because the light was actually bent and you would just see them at a different location. And this was a definite prediction, and because we knew the mass of the sun, Einstein could predict precisely the shift in the angular position of the stars. And one cannot usually observe a star near the sun because the sun is so bright. One can do it during an eclipse. So this is precisely what these two teams of astronomers did in 1919. There was a total solar eclipse, and this very famous British astronomer and physicist Eddington and colleagues basically went to the southern hemisphere, to the Africa and Brazil, to take photographs of the sun, the stars near the sun, and they indeed verified that during the eclipse the position of the stars were actually shifted as compared to the same stars that would appear in the night sky. So that really made Einstein's theory, it's something that's not seen in Newtonian gravity, and you could verify it using a direct observation. Now, this is not the only thing that Einstein theory predicted. Einstein theory predicted the existence of black holes, gravitational waves, things like gravitational time dilation, etc. All of this have been verified with a large number of very precise astronomical observations, as well as laboratory measurements. But the most dramatic, perhaps, prediction is that the universe itself is expanding. And this is something that is unimaginable. Even Einstein could not believe it, so he had to put some extra terms in his equations by hand to make the universe static, because something that is very, very hard to imagine. Just like for the ancients, it was so hard to imagine that Earth is not the center of the universe, right? Still, even for Einstein, it was very hard to imagine that the universe is not static. It's an unsettling idea. But again, starting from 1930s, a large number of astronomical observations have verified that universe is indeed accelerating, expanding. In fact, in the last 2 decades, we also know that the universe is not only expanding, the expansion is in fact accelerating every day. This is a new puzzle for astronomers to solve, astrophysicists to solve. So, does it mean that, so Einstein's theory has been incredibly successful. It has basically explained all the astronomical observations practically that we know until now. It has passed all the laboratory tests with flying colors. But does it mean that this is the ultimate theory of gravity? Does it provide the ultimate theory of the universe? No. We know the limitations of Einstein's theory because there is this other very important branch of physics that looks at phenomena at very small scales, microscopic scales, called quantum physics, that describes electrons, atoms, and fundamental particles, etc. And it turns out that the Einstein's theory and the quantum physics cannot be combined. There is a fundamental disagreement between them. That's another problem for physicists to solve in the next century or so. So we know that Einstein's theory is not the final theory of gravity, but until we wait for a better theory, it provides an incredibly useful tool to explain a large region, large spectrum of natural phenomena. So just like engineers, scientists are also physicists at least are very pragmatic. Like, you know that this is an approximation, but just like in engineering, you don't try to build a perfect structure. You try to build a system that works, right? And it works for most of the time. The failure chances are extremely small. So this is the thing. The clever technique, that comes from experience for being a physicist. The trick is to know what is the right kind of approximation, what is the right kind of error that you can tolerate. So while we wait for a better theory, this is providing a very incredibly successful theory. And basically, the progress of science is basically due to its adherence to these two principles. One is that you have to invoke reason, you have to adhere to evidences, and you have to have a willingness to revise your explanations based on new evidence. And this is rather different from many other systems of knowledge. So for example, religion, right? Religion has an absolute belief in something. And based on observations or experiments, you are not allowed to revise your belief or practice. It's a very different system of knowledge. And the success of science in the bigger issues, it's a pseudoscience that I will come to later. So the success of... So for example, religion, right? Religion has an absolute belief in something. And based on observations or experiments, you are not allowed to revise your belief or practice. It's a very different system of knowledge. And the success of science in the bigger issues, it's a pseudoscience that I will come to later. So the success of science is based on its willingness to refine based on evidence, basically. And it is because of that, science has produced an incredibly large impact in producing technology, right? All the technology, if you look back, has its roots in fundamental science, a few decades or a few centuries ago. So, for example, there is this very famous story. I don't know if it's true or not. A couple of centuries ago, Michael Faraday was doing all these interesting experiments using magnets and coils, etc. He was a very successful public demonstrator. He used to give these Faraday lectures, which are very, attended by a large number of popular audience, etc. And he would show this coil, magnets putting in the coil, etc., and show this new phenomenon called electricity. And apparently one British minister asked, it's all great, good, fun experiment, what is the use of it? And the story is that Faraday told him that, sir, one day you will be able to tax this. Now you can imagine a world without electricity, right? And it was a very curiosity piece at that time, a century or two before. Similarly, all our telecommunication, radar, radio, microwave, television, all based on Maxwell's theory of electromagnetism. And Maxwell was an incredibly shy and introvert who worked on, in his sort of small office without really having any thought of what kind of implication they would have. All the electronics is a resultant of quantum theory, right? A quantum theory, the understanding is very esoteric, but it has large practical applications. There's an estimate that the impact of quantum mechanics is a few $1 trillion, basically. So it contributes a few $1 trillion to the economy, basically. Even very esoteric theories like Einstein's theory of gravity, the general theory of relativity, which tell that the space-time is curved due to gravity, etc., has now practical applications. Most of us use Google Maps, and they use a technology called GPS, the Global Positioning System, because even if you have a map, you need to know where in the map you are, right? And that is done by using signals from a system of satellites called the GPS satellites. They form a fixed coordinate system by orbiting around the Earth, and receive the radio signals from 3 or 4 satellites, and then using triangulation you place yourself in the map. And all these satellites have very precise atomic clocks which measure time with a factor of a fraction of 10 to the minus 12 second or 15 second, etc. But the problem is that, according to Einstein, gravity affects the flow of time. Gravity curves the space-time. This means that a clock on board the satellite would run slightly faster as compared to exactly the same clock here on the difference is very small, like it's like a nanosecond thing. If you do not correct for it, the GPS will become inaccurate in a matter of minutes. So an esoteric theory like Einstein's theory has now become part of the technology. So it is fair to say that all the technological revolution essentially happened because of the advancement of science in the previous years, and hence it really contributed to the economic well-being of the world, the modern societies of the last couple of centuries. But the impact of science is not only related to technology. Just like scientists evolved this understanding that one can explain the natural world using physical laws, people are expanding this idea, this thought of idea, right? Essentially, why can't you explain the social phenomena, the political phenomena, again using reason and evidence? So one could apply the same scientific method to explain the society around them. Of course, human societies are much more complex than the physical system that we deal in physics or even biology. They're incredibly complex. However, they still have a limited explanatory power. That's why we have economics and sociology and history, etc., etc. And this actually resulted, it's just like science has a practical consequence, which is the technology. Better understanding of human society is also resulted in social change. It has this practical application of social change. And in fact, a lot of the liberation movements happened in the previous century, 20th century, has their intellectual basis in the better understanding of societies through scientific methods, social sciences. And one particular example from our own history, the British rule had a couple of centuries of history in India, right? And it was not clear actually whether British rule was actually doing any good or harm to India. There were people arguing both sides because there is of course we see the oppression and so on, but also people are arguing how we are getting railways and English education and all these things. So it was not clear at the end whether they are doing any good or bad. So this very interesting person, Dalabhai Naoroji, did a very, very careful economic analysis of the situation. And he got it almost right also. So he, using a very sophisticated, not as sophisticated, but in a very careful analysis of the economic situation, he basically argued how the colonialists basically drain the resources of India and are causing the impoverishment of its people. So he has this drain theory was very, so he wrote this book, and this is called the drain theory, and this had a huge impact in shaping up the national movement, pre-Gandhian time. So the intellectual basis for the national movements actually came from this very careful economic analysis of the situation in India. So it's one example how, one concrete example that we can relate to how a better understanding of the societies can cause positive changes in the societies also. So this is how we, the modern society sort of benefit multiple ways from science. But also, one should be careful to distinguish between science and pseudoscience. There are, other knowledge systems that pretend to use the language of science. They use the language, but they are not really using the scientific method, and there is no adherence to evidence. There is no careful checking of the facts, etc. And they are totally incompatible with the modern practice of science and the scientific method. And one big example is astrology, which has a huge impact all over the world. Right? Astrologers use terms that sound like science, but it has no predictability. And in fact, it's a very compelling argument, right? For example, the premise of astrology is that the position of the stars at the time of your birth determine significantly your future. And it's a very potentially interesting claim. One has to take it seriously, and people have taken it seriously. But the question is, does it have any predictive power? And there are now very good ways of testing it. For example, if an allopathy, if a modern medicine, if you discover a new medicine, there is a very standard way of testing it. The idea is that because sometimes you get a cure without a medicine also, and it's very complicated. The human body is very complicated. So what doctors do is something called a double-blind test. So they take a large number of, ideally large number of patients who are suffering from a particular disease or a condition, and they split them into two groups. And one group is given an actual medicine, and one group is given what is called a placebo, which looks like a medicine but has no effect. It is just a placebo. But neither the patients don't know whether they are getting a real medicine or a fake medicine or a placebo. And the doctors also don't know whom they are given the real medicine or the fake medicine. And there is a translator between them. There is a controlling authority. So only if the group that was received the real medicine gets significantly better result as compared to the placebo group, you can claim that this medicine is effective, right? Otherwise, it's a random effect. So similar, double-blind studies have been done in the astrological predictions also. There have been several tests done in like one very famous test in France was this very thing, they got a large number of horoscopes from very eminent people, best scientists, artists, writers, leaders, etc. And the same number of horoscopes from the worst criminals in France. And they blinded them. For example, a horoscope does not, they won't tell you whether the horoscope corresponds to a criminal or an eminent person. And they gave an open call to astrologers to distinguish whether, I give you a horoscope, you need to tell me whether this belongs to a criminal or an eminent person. Again, there is a statistical chance of success because if you toss a coin and you make a prediction, there is a 50% chance of success, right? So if you factor that in, they were not able to show any additional predictive power for horoscopes. There are similar studies done in India also. One very interesting study was led by a very famous astronomer, cosmologist, Professor Jayan Narlikar in Pune, along with a group of astrologers also. What they did was to, again, schools in Maharashtra, and same number of horoscopes from special children which have various mental difficulties. And again, the same call for astrologers. You need to, from the blinded horoscope, you need to tell whether this belongs to a so-called bright student or a special child. Again, there was no excessive predictive power of astrology. So all these have refuted such claims of pseudoscience beliefs, but still they run very root because of various sociological reasons. However, unlike the case of pseudoscience, there is not direct conflict between religious beliefs and science. Right? As I told you, as J.B.S. Haldane said, it is only your practice of a scientist have to be atheist. In your personal life, you can be atheist or it doesn't matter. And this is very famously articulated by this evolutionary biologist called Stephen Jay Gould. And he essentially described that science and religion operate in two known overlapping spheres. So one deals with material world, explaining phenomena in the material world, and religion should just stick to the spiritual world. One has to discuss about values and so on. And if you limit the validity of these respective knowledge systems or intellectual practices into both their respective, there is no conflict. However, we see sometimes otherwise people try to apply their religion to material worlds also, and there's also this ideology called scienticism, where there are people who believe that science can solve all the problems of the world. It's also not true. Especially if you try to use your religious thought or religious text in describing the literal interpretation of all the religious texts, then the material world is sometimes inconsistent with the literal interpretation of the religious texts, right? And we know this very famous, infamous controversy in the Renaissance Europe between Galileo and the Catholic Church, right? This Galileo's observations that supported the heliocentric theory, the fact that the sun is the center of the solar system, did not go very well with the dominant thought at that time. Even though there is nothing very religious about that, it's the dominant thought of that time, right? But later, Catholic Church officially acknowledged this mistake, and they admitted that there is no conflict between this heliocentric theory and religion, etc., etc. Again, in the modern world also we see different versions of that. In particular, even in very developed societies like the USA, there is a huge resistance to the modern understanding of how the species evolved through the evolution of other species through process of mutation and natural selection. This is famously put forward by Darwin and Wallace. So this is the most successful theory in explaining all the observation phenomena in the diversity of species and all the archaeological record, the paleontological record, and etc., which say that basically all of us come from a common ancestor, and they split because of mutation, and certain species survive because of this idea of natural selection. Again, biology has no particular adherence to this theory. This theory is received because this is the one that has the best explanatory power, that is supported by all the evidence. And if tomorrow someone comes with a new theory that has a better explanatory power, there is no reason why biology should not accept this. But there are actually a lot of pseudo-scientific claims, such as called creationism, called intelligent design, etc., which make some very childish criticism about this theory, and they are all. Problem is that this theory of evolution is in conflict with a literal interpretation of certain religious texts. This is not, again, how much time I have?
You have time. This is what.
Sorry?
What?
Oh, fine, okay. 5 minutes, or I'll finish in instead of 5 minutes. Okay. Thank you. And the conflict of science is not only with certain religious interpretations only. Another modern theory or modern understanding that is meeting with a lot of skepticism, especially in the US again, is the idea of climate change. So again, the last few decades we have enormous observational evidence that suggests that the average temperature of the globe is increasing over the years, and it is contributing to a significant amount of large-scale change in the global climate. Here's an actual observational data which shows how the average temperature in the globe is changing as a function of time, 1850 to 2020 or so, and you see this sharp rise. This is a normalized to zero in 1850, and it's going up like this. And it has a very high correlation with the abundance of the so-called greenhouse gases in the air, in particular the carbon dioxide and methane, etc. And the scientific community is practically unanimous that the climate change is real and the human activity is the prime source of that. However, if this is true, there is some amount of consequence, right? For example, this means that we know that this is primarily caused by fossil fuels. So the fossil fuel industry is very threatened about this finding. So they have funded a large number of sort of think tanks which would inject skepticism about these findings by poking holes in their argument, etc. And again, they were worried about, if this is true, then it means that one has to impose some level of global control on their activity, right? And this is against this idea of free markets and so on. So there is a lot of ideological opposition also to the finding. So it's not that, the real issue is that what is the consequence of this finding? If this finding was actually true, what is the consequence of that? It is going to affect certain people, certain fraction of interest, and they have basically, they are fueling a lot of skepticism against this kind of finding. But practically, the scientific community has almost complete consensus that this is real. Just like there is no question about evolution among scientists. They all accept that this is the best explanatory theory. But does it happen only in the Western world or in the Middle East? Not really. So luckily, in India, we don't see a lot of skepticism about evolution or climate change, etc., because in some sense, it doesn't really affect our way of life so much yet. However, we have a lot of issue about our understanding of history. So just like in any other branch of science, history is also a social science which has a rigorous scientific method. It has adherence to evidence. It follows the reason has to be consistent, etc., etc. And basically, professional historians have agree on a broad paradigm on the Indian history. They know how to understand it. They have evolved what is called a historiography, etc. However, this is in conflict with the religious, the dominant communal ideology in the country, which basically presents the Indian history purely in a communal prism. It just describes some very ancient, glorious India and foreign invaders, etc. And it's we know that there is partly truth in it, but it's a very simplistic analysis which really doesn't understand the complexity of this history, etc. And again, the criticism, the poking holes come not from professional historians. They come from primarily from political interests. So to summarize, the resistance to the various branches of science in modern societies essentially stem from concerns about the consequences of the discovery, not really from the practice or the accuracy, or not even the concern about the truth. If this is true, what would happen to certain interests? That is the issue. But the problem is that if you just accept only the facts that are consistent with our beliefs, then what are facts, right? Everyone else, they're going to have their own facts. So we are just going to have the whole confusion that people experience in the medieval centuries, right? And we know that human societies were able to make significant progress in the last centuries because of certain systematic understanding of the world and how this understanding was used to transform the world by means of technology and social change. And essentially, at this point, there's a huge threat from this conflict between your personal belief and the acceptance of truth. So let me stop here, and what I try to convey in this National Day of Science is that in the past few centuries, the humanity has constructed a systematic way of acquiring knowledge of the material world based on reason and evidence. And the core of this knowledge system is what is called a scientific method. And the conclusions derived from this method undergo systematic scrutiny, re-verifying their theories, a very much part of the science, and revision. And there is no adherence to any particular theory. I show you an illustration how this understanding of the universe evolved from Ptolemy to Einstein. And this ability to understand the natural world as well as the social phenomena resulted in technology as well as social change, which really contributed to the progress and the well-being of the modern societies of the last century or so. And however incomplete, science remains really the best way to understand the natural world. So it is really a candle in the darkness. This is a famous book by Carl Sagan, the American space scientist. So I strongly recommend his books. And there's this very famous book called The Candle in the Dark, which I strongly recommend all of you. So let me stop here, and thank you very much. I don't know if there is any practice of taking questions. What is the... Okay. And if there are questions, I'm happy to take or comments or disagreements also. Thank you.
Hello. So floor is open for the question. Students can have question. Please raise the hand. We got 2 mic. Okay. Sir.
Does it have any effect on the life of
Sir.
climate change?
No.
Does this have any effect?
No, so the question is whether the universe, the expansion of the universe has any effect on the Earth, on the life, etc. No. It turns out that the expansion happens in a much larger scale, even bigger than the galaxies. So our galaxy has like 100 billion stars, and our sun is just one among them. But this galaxy itself is not expanding due to the expansion of the universe. It is bound by the gravitational force between all the stars and etc. But different galaxies that are separated by several millions of light years are away, receding away from each other. So the only consequence that you would see after billions of years is that all these distant galaxies would be so far away that you won't be able to see them. That's the only consequence. But this would happen only after billions of years. So it has no practical consequence to life. However, let me make this opportunity to make an interesting remark, which is that we would imagine most of the time the astronomy has no consequence to life, right? But it turns out that there is this beetle called dung beetle, which is able to navigate it through its place at night. And it turns out that it is actually using the polarized light from the galaxy to find its way. And biologists have actually tested this by essentially, if you just cover if they put them in lab, they would be completely confused. But what they do is they put it on a desk under a planetarium, and they projected the galaxy on the planetarium dome, and they were able to easily navigate. It's a very curious creature, which is actually seems to use the galaxy to find its way here on the Earth. So there are many questions I hear.
Yeah. Hello, thank you for nice, crystal clear. We can, from the talk, understand how clear your idea is. So you can give a layman language, the strong physics and also social relations with the science. So from school time, one thing I couldn't understand. Now I am a biologist and I work little bit of microscope, and so when comes the light, in sometimes in microscope many times we talk about photon, and just we are counting and detecting the photon. Then concept of comes that light wave as a kind of mass. Probably that is because Einstein, when it's a strong gravity, but many times when explanation cannot go with the photon, then they come, says light is a kind of energy and wave. Yeah. So as a microscopist, when we detect some detector, many times as a measurement unit we bring the photon, but I never couldn't understand what is what. And sometimes when we measure the laser power, then we come complete to the energy.
Yeah.
So maybe it's too much technical, but I feel this from childhood I could not clear. You are the perfect person. If little bit layman language, because I am not.
It's very interesting. It turns out that light is a curious object that shows both a quantum nature, which means that they are discrete quanta of energy, it also has wave nature. It turns out that it is not only light, but every particle has both a wave nature as well as a particle nature. In fact, we think of electrons as particles, right? So they should not have any wave properties. But just like when people have done this interferometry experiment, I know this very famous Young's double slit experiment, where you shine two light beams and interfere them, you see interference pattern. And people that have done experiments using electrons also, they show the same interference pattern. So it seems that according to this theory of quantum mechanics, every particle has a wave nature also. But depending on the mass of the particle, this wave nature becomes more or less apparent. The world is that weird. In fact, I don't know what is more to, what more can we tell about that.
Okay, thank you and another just thing, don't you think still that Galileo times exist if some big scientists still give little bit wrong theory or not exact theory to, even as a new scientist bring the new theory, it's very difficult to replace it until this big shot dies. So what is your opinion about it?
Yeah, so this is just like any other human activity, the practice of science is a human activity. It is marred with all the imperfections of usual human activities, right? So there are issues of in the practice of science. There are dominant groups, there are dominant people, there are dominant countries. And if a bright idea comes from a less dominant person, a less dominant country, a less dominant society, it takes away a lot of time to get into the system. However, the point is that eventually it will, because if you have more and more observational evidence, more and more experimental evidence, which is supporting this new theory, even if it's come from a young scientist, eventually one has to accept it. And that has been the history also.
Again, I'm a biologist, but I have always been, my first love has always been physics. So please pardon me if my question is wrong. Randomness is a way of nature, right? Orderliness is not, even if you go by thermodynamic principles. So based on that, you're predicting the path of the planets based on some amount of orderliness. So can you actually predict when the Earth will end? Because ultimately it's going towards chaos, right? Randomness is not the law. So can we predict the planet's life, or coming to to our Earth itself? Can we predict when this order will be completely lost?
The order will be completely lost.
Yeah.
Yeah, the point is, even though we know the theory to describe these things, you can solve these things or only on simple systems. For example, a system of planets around a central system is a very simple system, one can solve it. Eventually one would hope that even things like a cell, right, would be described eventually by all the fundamental particles, because eventually cells are made up of molecules are made up of atoms and protons and electrons and so on. So one would hope that eventually even the entire dynamics of a cell could be derived from some fundamental physics laws. But we are unable to do it because this is too complex a system to apply it. So the difficulty is that the systems involved are too complex to solve the relevant equations and make a definite prediction.
And when you make the equation, you always assume it to be idealistic without...
Right, the equations are probably not, exactly, because if you are applying a set of theory to a system, and that is idealized, basically. Now, we believe it or not, the stars are simpler than planets. So one can actually predict the evolution of stars much better than the planets. So for example, if you are observing a star, astronomers can tell you how old it is, what its fate will be, etc., because we understand the physics much better and the physics is much simpler.
So mathematically we can predict it based upon orderliness versus chaos, and when it will...
I mean, that is not...
of energy.
Not that simple, I'm afraid.
Okay. I'm just asking a name.
No, not that. Yeah. So the chaos is basically the fact that even if you have a theory, if you know everything, even a small change in the initial conditions would give you a very different final result because the system itself is very complex. Chaos, sorry? Yeah.
Can you predict that?
I mean, there are ways of predicting when a system becomes chaotic, etc. There are these called logistic maps, and there are mathematical ways of defining how a system, when a system would become chaotic, and so on, given initial conditions. Yeah, but it's very hard to predict, for example, how the planet would evolve tomorrow because there are a lot of changes happening. Right?
One small question that I have, we have all been watching science fictions. So the question that comes to my mind, is it really possible to use the eclipses, especially solar eclipse, to predict the end of a particular planet? I mean, the way it was all hyped up in 2012 that the Earth would come to an end, and then we all really thought and felt it's going to come to an end. Is that possible
No,
from
this is
the
what I call
eclipses?
pseudoscience. There's absolutely no reason to believe that. So, eclipses happen because the moon happen to be in between the sun and the earth. And we can very accurately predict when the eclipses would happen and so on. I mean, there are historical reasons why people were afraid of eclipse, right? Because suddenly, if you don't have any understanding of how these things work, suddenly in the middle of the day you would see darkness and people would get scared. But now over centuries we have understood how these things move, and we have very accurate predictions of when the next eclipse would happen, which parts of the world, etc. There's absolutely nothing to worry.
Sir, I have a doubt. So recently there's been a major breakthrough where few scientists and computer science engineers, so they basically simulated a holographic wormhole using quantum computers at Google. So this is probably the first time in history where quantum mechanics was used to describe something of a celestial body, which is probably more related to the relativistic physics. So my question is, let's just say we don't nuke ourselves out of existence. In near future, can quantum mechanics and relativistic physics might be different pieces of the same puzzle, or are they competing against each other to be a better fit in the whole puzzle?
Okay, I did not fully understand the question, but I understand the question is basically about the compatibility of the quantum physics and the general relativity. Yeah. So so the validity of quantum mechanics is describing phenomena at microscopic scales. That's where this wave nature of particles, etc., become more apparent. That's why we don't worry about the wave nature of a cricket ball, while we need to worry about the wave nature of a proton or an electron. But at the same time, at large scales is where the general relativity plays a role. But and these are fundamentally incompatible currently. But there are places in the universe where we would need both. First of all, what would happen inside the black hole, in the singularity, where everything will fall into a very small region, and the gravity is extremely strong, and we need quantum mechanics also. We have no way of describing that right now. But the hope is that just like Newton's theory was derived from Einstein, you could derive now Newton's theory from Einstein's theory, because Einstein's theory is a more general theory. It has a more universality. It has a largest scale of applicability. The hope is to find a new theory from which both quantum mechanics and the general theory of relativity could be derived. It's a very difficult problem. There are many approaches to it, and there is like string theory and various versions of quantum gravity, and people have been working on this, but
Thank you, sir. Thank you for your inspiration and encouragement. It is a pleasure to have you in spite of your preoccupations. Your presence made this day a memorable day. Thank you, sir. May I now request our Director, MIT Bengaluru, to present an appreciation memento to our chief guest.
of National Science Day Celebration 2023. To begin with, we have the prize distribution for various events held at Manipal Institute of Regenerative Medicine. May I now request Dr. Uttara Chakraborty, Coordinator for NSD 2023, to proceed with the same. Madam.
Thanks, Dr. Ramya, for inviting us and me on stage right now for this distribution ceremony. First of all, I would like to thank the entire Mahe Bengaluru scientific fraternity for having us here for this program and celebrating this wonderful day together. And this is that part of the section of the day when everybody, generally our students, are awaiting to get the prizes and awards. So first, before we begin with the Science Day Celebration Awards, there is a very unique award which we give out every year for our outgoing students. So I would like to begin with that, calling our students here, and followed by that the events which we had actually conducted in MIRM yesterday accordingly. To do the honors for the first set of certificates, I like to invite Professor Ajith on stage to please do the honors. I would like to call Mr. Anjan, who has received the Certificate of Excellence as the Best Outgoing Student from the year 2020 to 2022. The second award for the Certificate of Excellence goes to Tejashri from the same year. Please come up on stage. The next Certificate of Excellence goes to Ms. Srinidhi, 2021 batch. Come up on stage, please. The second award goes to Ms. Althea from the same batch 2021. I would request come up on stage. Thank you very much, Professor Ajith, for doing the honors. Now we'll begin with the certificates of merit to our students who have relentlessly worked up a wonderful program yesterday in organizing quizzes and poster sessions for which they deserve to be awarded. And for that, I would really want to call up on stage and invite our Dean, Dr. Sudha Warrior, to do the honors. So the first set of awards certificates are being given to the quiz winners. Again, I would like to call on the students, Ms. Srinidhi on the stage, Ms. Annapurna and Mr. Anil. The second winners for the quiz The second team participants, please come up here. Ms. Vidisha, Mr. Anirudh and Mr. Sandeep. So after this, coming to the poster sessions, we actually had 8 independent groups who had presented posters yesterday, showcasing their research activities which are going on in their groups. And the first group that has been selected to get the Best Poster Presentation Award is Dr. Ajith Kumar's group. I would request Dr. Ajith to please come up on stage and receive the certificate. If the group is here, you can all please join Dr. Ajith. The second, as one would say, the runners-up team has been from Dr. Manasa Nune's group. I would request Dr. Manasa and if the students are around to come up on stage to receive the certificate. Thank you, Dr. Sudha, for the awards to do the honors. With this, I would again pass on the stage to Dr. Ramya and to the MIT for their award distribution. Thank you.
Thank you, Madam. We may now have the prize distribution ceremony for the various events held at MIT Bengaluru. All winners will be receiving a rolling trophy, appreciation certificate, book and Amazon gift voucher. Starting with, we have the winners of audio-visual creation on the theme Life and Work of Sir C.V. Raman. Before announcing the winners, we have the audio-visual of the winners to be played.
The first Bharat Ratna, the first Indian director of IISc, the first Asian to win Nobel Prize in Physics and the first National Professor of India, Sir C.V. Raman. Born on 7th November 1888 in a small village in Trichy, C.V. Raman had always been a precocious child. He joined Presidency College at Madras in 1902 and completed his secondary and higher secondary education at a young age of 11 and 13 respectively. Later, he obtained a BA degree where he stood first in both English and physics at the age of 16. First research paper. He published his first research paper on the diffraction of light while he was still pursuing his master's. He completed his master's degree in 1907 with highest distinction from the institute. Immediately after completing his master's degree, he joined Indian Audit and Account Service, a post under the Indian Finance Service, as the Assistant Accountant General and taking his first post in Calcutta. One of Raman's interests was on the scientific basis of musical sounds. Raman studied the uniqueness of Indian drums. His analysis of the harmonic nature of the sounds of tabla and mridangam were the first scientific studies on Indian percussions. He contributed majorly in acoustics and optics in association with Indian Association for Cultivation of Science, AICS, which was also for the first Indian Research Institute. Meanwhile, he was transferred to Myanmar, but soon he came back to India due to his father's death, which compelled him to stay in India. In 1917, he resigned as a civil servant. Though his salary was reduced to almost half, it gave him more freedom to do his research work. The Golden Era. In 1919, Raman received 2 honorary positions in ICTS, first as honorary professor and second as honorary secretary. Referring this period of time, he describes it as golden period of his life. He started investigating the phenomenon of scattering of light, His major breakthrough in the field of physics is considered as the discovery of phenomenon of the blue color of seawater. He observed this during a voyage to home back from England, being hosted by the British Empire. In 1921, he delivered a lecture at Congress of Universities of the British Empire, which was hosted by Nobel laureates J.J. Thomson and Rutherford, who are very well-known scientists. The Raman effect. On 20th February 1928, he discovered the Raman effect, and this day is celebrated as National Science Day by the Government of India in remembrance of Sir C.V. Raman's contribution in the field of physics. Raman had a sense of obsession with the Nobel Prize. In a speech at the University of Calcutta, he said, "I am not flattered by the honor done to me," while he referred to the fellowship to the Royal Society in 1924. "This is a small achievement. If there is anything that I aspire for, it is the Nobel Prize. You will find that I get it in 5 years." Soon after which he received the Nobel Prize. He was asked in an interview the possible consequences if he had discovered the Raman effect earlier, which he replied, "Then I should have shared the Nobel Prize with Compton, and I should not have liked that. I would rather receive the whole of it." Becoming the director of IISc. In 1933, he moved to Bangalore and became the first Indian director and fourth director of IISc. He also founded the Indian Academy of Science the very same year. With his former student Panchapaksha Krishnamurthy, Raman started a company called as Travancore Chemical and Manufacturing Cooperative Limited in 1943. The company, renamed as TCM Limited in 1996, was one of the first organic and inorganic chemical manufacturers in India. In 1947, Raman was appointed the first national professor by the new government of independent India. In 1954, Raman became one of the first few people to receive the Bharat Ratna, the highest civilian award in the country. At the end of October 1970, Raman had a cardiac arrest and collapsed in his laboratory. He, however, survived a few days and requested to stay in the gardens of his institute, surrounded by his followers. That evening, Raman met with the board of management of his institute and discussed with them the fate of the institute's management. He also willed his wife to perform a simple cremation without any rituals upon his death. He died from natural causes early the next morning on 21st November 1970 at the age of 82.
I request our Chief Guest Professor Ajith and our Director MIT Bengaluru to distribute the prizes. And as you've seen, the winners for audio-visual creation are Rishikesh Odiyar, first year CSE AI, and Patel Sujal Vipul, first year CSE AI. Congratulations, winners. Next, we have the winners for quiz, science and technology themed. Winners are from the team Cosmic Warriors, Ajith Tandalveda, first year computer science core, and Sithik Srivatsava, first year computer science core. Next, we have the runner-ups from extraterrestrial, Samarth Asija, first year CSE Core, and Amar Aziz Safi, first year CSE Cybersecurity. Along with this, they receive an Amazon gift voucher of ₹1,000. All winners. Next, we have the winners for debate. The final theme, basic science is necessary in engineering. And the winners are affirmative arguments, cosmic warriors. And we have repeated winners here. Ajith Tandilwada, first year CSE Core, and Shikit Srivatsava, first year CSE Core. They were the winners for the affirmative arguments. Now we have the winners for the opposing arguments, and once again repeated winners. And the winners are extraterrestrial, Samarth Asija, first year CSE Core, and Amar Aziz Safi, first year CSE Cybersecurity. Next, we have the winners for the poster theme, Global Science for Global Wellbeing, and we have the handmade poster winner, Yashmeet Singh, first year CSE Cybersecurity. And the winner for poster digital making goes to Ritik Balwan, second year CSE Cybersecurity. Congratulations, winners. Success is no accident. It is hard work, perseverance, learning, and most of all, love of what you are doing or learning to do. May I now request Dr. Manasa Kangot to deliver the vote of thanks.
Good afternoon to all. As we reach the end of our celebration of this National Science Day for 2023, it is my utmost responsibility to deliver my words of gratitude. Firstly, I thank Professor P. Ajith, who has taken out a day's time from his busy schedule and enlightened the gathering about various aspects of cosmos and how science can impact and induce positive influences in society and our general understandings. He beautifully bridged connections between science and various aspects of our daily lives. We would definitely like to have you here in future for more such inspiring talks, sir. Thank you so very much for your attending. Thank you. I would next like to shower my gratitude to Dr. Pragna Rao, Pro Vice Chancellor, Mahe, Bengaluru, for her honorable presence on this occasion. I also express my gratitude to Dr. Sudha Warrior, Dean, Manipal Institute of Regenerative Medicine, whose gracious presence has added another dimension to our Science Day celebrations. My sincere and wholehearted gratitude to Dr. Jagannath Korodi, Director, MIT Bengaluru, for his presence, his everlasting and enthusiastic support to our team. When we went to him with our plan, he readily agreed and gave us all kind of support we needed towards the conduction of various events. Thank you so much. I cannot forget to thank all the lovely student participants who actively took part in the various events conducted on account of Science Day. All of them did so well, and it was a very tough call indeed for the judges to evaluate and decide on the winners. However, your enthusiastic participation is which made our event successful. Thank you so much. And I thank all the faculties of sciences who have given tireless inputs and efforts in conducting the various events and also for today's event. Thank you so much. And all faculties and coordinators from MIRM Bengaluru who are here, thank you so much. I also thank the student council members, mainly Devanshu and his team, for helping us out throughout the events. All other student volunteers, there are many student volunteers. We have around 30 to 35 student volunteers who have helped us throughout the event. So I cannot name everybody of them. So I would like to collectively thank the entire student volunteers from MIT Bengaluru who have helped us in the last 1 week. I would also like to thank our sponsors. We have had 5 sponsors for this event who have helped us with who have given us such beautiful rolling trophies. And I would also like to thank all the technicians, security, reception who have helped us in various occasions, and all the non-teaching staff who have helped us. Kanchan ma'am for helping us with various things, also the canteen facility for the food. And along with that, I also thank Ramya ma'am for graciously moderating today's function. Along with that, I also thank the stage committee members and all the other students who have helped us. Lastly, I also thank the coordinator of National Science Day, Dr. Utpal sir, without whose support and help we all couldn't complete this event. I also thank Manipal sir for allowing us to hear such a great talk from Professor P. Ajith, who was able to connect with him and was able to bring him over here. Thank you so much, sir. So if I have missed any names, kindly excuse me. Thank you so much.
Thank you, Dr. Manasa, who is the co-coordinator of this event. Thank you. We may now gather for a group photo along with all the participants and the prize winners. An announcement for all the participants. All participants and volunteers will be receiving certificate. Kindly collect it from Dr. Manasa on Monday. Now we can gather for a group photo.